Good morning. Now today, I told you yesterday that we would be using a formula to be able to find the nth term in a sequence, and that is what this is right here. I wrote the page number that the formula is on so that you can go look on that page and you can review it, or I can just show you exactly how we're going to use this. So we've got a sub n, so a to the any number of term, that's what that stands for, is going to equal the first term times the common ratio to the exponent of the term you're trying to find minus 1. So what we're going to do first is I'm going to show you how to write a formula once you know the common ratio. So we're going to use this sequence right here. So this is example D. We've got 10, 30, 90, 270, 810, 2,430. So we're going to find the common ratio first by doing 30 divided by 10, and that's going to give me 3. So next we are going to write the formula, okay? So a to the nth term, so any term is going to be the first term, my first term in this sequence is 10, times r, notice it says r right here, so r is 3 to the n minus 1. Now, note, I am keeping that as a multiplication sign here because according to PEMDAS, we have to do exponents before we do multiplication. So I need to make sure that I am putting that common ratio to the proper exponent before I multiply it by the first term. And this is going to be our formula here. Give me a second and I will have our next example written out. Okay, and we are back with example C. So for example C, the first thing we need to do is we need to find our common ratio. So we're going to do that by setting up r equals 8 divided by negative 16. So it can be any term divided by the previous term. I'm just going to do second term divided by first term, and that's going to be negative 1 over 2. I almost wrote my 2 without my sign. Okay, so my common ratio is that. A couple things I'm going to go ahead and write here is I'm going to go ahead and write down my first term, which is negative 16. I'm going to go ahead and write down what n is, okay? Now we found that by simply looking at our first term and looking at what term it is looking for. Now, I want to note that your book is actually wrong in this example with the symbol for it, and I'm going to show you why. So we have to pay attention to the sign. Now their math is correct. So we're going to set this up by saying a to the nth is going to equal negative 16 times negative 1/2 to the n minus 1. Now this is the same thing as saying after we plug this in, it's going to be a to the 8th equals negative 16 times negative 1/2 to the 8 minus 1. Okay? And that's going to give us our final setup so that we can just jump straight into solving it as negative 1/2 to the 7th power. Now, I want to note here, this is a negative term to an odd power. When you have a negative term to an odd power, your term is going to be negative. So when we set this up and we multiply this out, so it's 2 times 2 times 2 all the way up to 7th power. So it's going to end up being negative 16 times negative 1 over 128. Okay? When you work this out, you're going to end up, because you can cancel out 16 from both of these, you're going to end up with a positive 1 over 8, which would equal a positive 0.125. Now your book has this down as a negative. It is in fact a positive here. So don't worry, I will be double checking. Thankfully you don't have the answer key to your work that you're going to be doing, so I will be double checking with those to make sure that you get the proper signs versus what the answer key may have. Okay, now the reason for that is, like I said, an odd power of a negative number is going to be a negative number. So we have a negative 16 times a negative 1 over 128, which is going to give us a positive 1/8. So if any of you guys noticed that in your example, you were correct, and congratulations. So don't worry too much. I can see where that would have been causing some complications. I'm going to go ahead and rewrite your next examples as well, and we're going to jump into the last part of 10.4. Okay, and for our final set of examples here, we've got example F and we've got example G. These two highly depend on the definitions of these two words right here. So I wrote you a little cheat sheet here. You need to know this. If the absolute value of the common ratio ends up being less than 1, the sequence does something known as converge. Converge means that it is slowly going to get to a single number. So it's going to move forward to where the sequence is getting smaller and smaller and smaller towards a single number. Now, if the common ratio, if the absolute value of it is greater than 1, the sequence is going to diverge. So in this case, if it ends up being a fraction, it's going to converge. And if it ends up being a whole number, it's going to diverge. So the first example they have is example F. And we have to find the common ratio of this. So what they simply do is they take this and they make it not a fraction, or they make it to where this is something to the nth power is not a fraction. So I am going to show you how they do that. They simply take this, and this is like saying 3 times 1/4. So I'm going to do 1/4 times 3 to the n. And here we have that our common ratio is going to equal 3. Now, if we look at this, the absolute value of 3 is actually going to be, well, it's a positive 3, which means that it is actually greater than 1, which means this whole sequence is going to diverge, okay? And that's our answer there. So now if we look at examples G, we have to then find our common ratio. Remember, it's any term divided by its previous one. So I'm going to do R equals 8 divided by negative 16. This should look very familiar. It's going to be negative 1/2. Now, my hint here is this is a fraction. So we don't really care if it's positive or negative because it doesn't matter because we end up taking the absolute value of it. So since this is a fraction, we can look at this as negative 1/2, the absolute value of that. It's actually less than 1, which means it's going to converge. So if our common ratio ends up being a whole number, either negative or positive, it's going to diverge. If it ends up being a fraction that is a fraction that's not an improper fraction, so if you could simplify the fraction down to having a whole number in front of it, that would still be a diverging one. But if it's just a fraction that's not going to be where the top is not larger than the bottom, just a normal, regular, everyday fraction that we see all the time, it's going to converge. So keep that in mind with these. So those are what those two little terms mean. I know it's kind of a odd little thing to throw in at the end here, but it's kind of fun to learn 2 new words. So converge means it's going to get closer to one number, and diverge means it's just going to get bigger and bigger, and it's not ever going to get towards one number or another. Okay?